Good morning. Hello. So, unfortunately, this presentation will be in English. Haven't learned Polish yet. I hope to at some point. Do love languages. So, just so I can get to know my audience a little bit, how many have been in OT or ICS for at least a couple of years? Hands? Okay. How many are from IT and have not been in the space? Okay, that's good. So probably about 2/3 have been in OT and about 1/3 have been in IT. For those of you in the OT space, how many of you are engineers? All right, fantastic. Okay. So this is me. Why should you listen to me? Why did they bring you an American here to talk to you about these things? I test really well. I've done a bunch of stuff. I'm a recovering regulator in the US. I've written federal laws, worked in multiple different verticals: electric, chemical, mining, gas, water, transportation, some stuff. Also, the company slide, most importantly, we do have a European branch, and I do spend a fair bit of time in Europe, so I do know the situation in Europe, speak at several conferences in Europe as well. So let's just set the stage and start the conversation. Every single thing out there, if it has not been hacked already, it can be. Everything. I have a digital toothbrush that was hacked. Cat feeder, hacked. Coffee kettle, hacked. Good friend of mine, Stephen Hill, just made a post yesterday about how his coffee machine was hacked because it was connected to the internet. Intelligence agencies, hacked. Drones, hacked. Already. Any single thing with a chipset can be hacked. If you don't believe me, you can ask this gentleman right here. He can probably find his way into almost anything. The issue is we have a very, very difficult job to do. Understand that. This is what we do. This is our job. It's difficult. It's going to be endless. It will never get to a place where we're done. And that's okay. We just have to accept that. That's why we did this. Honestly, if you're not thinking this, you're in the wrong business. There are people that say things like all of the smart everything that's been hacked that we just mentioned. There's too much IoT, there's too much IIoT out there. The vendors are making just garbage, and it's all hacked before we even get it. It's got 10-year-old operating systems in it with 20-year-old embedded systems that were written by somebody in a basement, and we've got to replace these things, and they're making them so fast that we can't keep up and we can't secure it all. We should just stop. Slow down. Secure it all before it goes to market. That's never going to happen. Innovation will only increase. We saw a slide yesterday from Marina Krotofil. Fantastic presentation. Thank you, Marina. You saw the innovation curve. We saw the Industrial Revolution. We saw the next Industrial Revolution. And the time was shrinking between each Industrial Revolution. If this is true, mathematically, it makes sense that we will reach a place where it is literally perpetual Industrial Revolution. If that time keeps shrinking and the innovation keeps going up, as those things compress, what does that look like? Will you be able to keep up? We are shrinking that distance, what I call the logical distance. That's getting in that space. At the same time, we're increasing the number of digital things between the person clicking on something on their screen and some field equipment doing something, like a pump or a breaker or an actuator. So the driver and the mouse, the near-field protocol that connects the mouse and the keyboard to the computer, all the different protocol stacks, all the different types of communication that happen between the person clicking on their screen on an HMI and some field equipment piece doing its thing. All of that logical stuff that gets in there is expanding. At the same time, the innovation and time is shrinking. This is an insane problem. Why did you sign up for this? Because that's what we do. That's our job. Hard job. So telling someone to stop innovating I have kids, and when you tell them to stop doing something, they do more of it. Anybody else who has kids, I see some smiling, you know what this is like. Anytime you tell humans to stop doing something, oh, no, 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 I'm going to do more of that, in fact. I'm not going to stop, I'm going to do even more of it. So when you tell someone to stop and slow down and secure it before it goes to market, not going to happen. If you try to get humans to stop innovating and stop creating, they do more innovation and more creation. This has happened in every single time there's been oppressive cultures and oppressive regimes. The people that are oppressed and been told not to create even more, and they just go around it. You will never stop innovation. We as security professionals have to figure out a way to embrace that. We have to come up alongside it, teach it good manners, so that we can figure out how to make this work going forward as we expand this logical mess that we're getting into, and as time shrinks and as innovation only increases. That's our job. Because every single thing will be digital. I come from a time in a plant where we had pneumatic control systems. Some of you may remember. I see some people with some gray like me. Then we went to digital. I mean, just getting to the place where we could run wires was a challenge because the buildings were so old. Some of them were like historic landmarks and you can't drill through the walls. Some of them had terrible chemicals like asbestos in them and you can't run wires in those places because it's harmful for you to do so. So what we've done now is we've gone to a place where we can put sensors anywhere, right? We don't have to run wires anymore. We can do this through all kinds of new wireless protocols. We used to have to spend lots of money and time to put a digital component or even a physical component. It was even worse when it was just physical, it was analog. Then digital got easier, then we could automate. We didn't have to put humans everywhere. We could put a computer in place of the human and automate that, which gives us the automation paradox. The more you automate, then the more critical the human action becomes because there's just this cascading effect after the human takes the action. So as every single thing becomes digital, like I said, I don't know why, but I have a digital, my toothbrush has a chipset in it. Do we need this? No, but that's the way things are going. Everything, this is a digital piece. Most of the badges now are digital. Everything we have will have a chipset in it. Everything we have will also be connected. Because if it's digital, why shouldn't it be connected? If it's digital, it creates data. Why not use that data? If you want the cool new digital thing, well, they'll give you a free service because they're going to monetize the data from your usage of that digital thing. That's how this works. That's how we get free digital stuff all the time. So, again, there used to be a time when there were wires everywhere, and now we're not going to have wires. We're going to have everything digital. Everything will be connected. This is the future for us. I think at some point we're going to have a place where there is really, you won't think about it. There will be no need to connect to a Wi-Fi. There'll be no need to connect to a new network. It will just seamlessly and automatically go between all the different spaces. There will be Wi-Fi everywhere, or connectivity everywhere, shall we say. At the same time, technology is getting smaller and smaller and smaller. I remember a day when an RTU was the size of like an American refrigerator. These were giant things, and still like almost cabinet size. Today's equipment is getting so small that it's like the size of an iPhone, and it'll do the work of 10, 20, 30, 40, 100 devices that we used to have in the old days. So we're getting compute power. I mean, let's be honest, like your phone has more power than the space shuttle and many other things that we use to like literally put humans into space and onto the moon and things. So the fact that we've got so much technology packed into smaller and smaller things, has anyone seen Smart Dust from MIT? It's literally things that are the size of a grain of sand. And these are sensors that can do wirelessly with no other connectivity, or with no wires. They're, exactly the size of a grain of sand. They can tell you temperature, light, chemicals, many other things. And this is used in industrial settings and hospitals and stuff like that. So we've gotten to a place where we've got sensors now that can run on nothing. And they're the size of a grain of sand. And that's today. Where is this going to be in the future? With nanotech and many other things, it's going to get to a place where Everything is digital, everything is connected, and everything is so small you don't even know it's there. It will be woven into the fabric of everything you do. So when all this stuff creates data, where does all that data go? If you're an OT operation, or if you're in any industrial control system, we used to have to, run a wire through some wall and put a sensor in, and that would go back, and everything that we sensed, every piece of that process that we wanted to monitor or control was very important, and it cost a lot of money just to get those simple areas. We had to really focus on what the costs were, because you had to get enough engineering into the process to keep it safe and reliable, but you also had to do it cost effectively. That's a difficult balance. Most engineers would like to have a lot more sensing and a lot more control over the process, but they're stuck with what they can afford in some cases. We don't have that problem going forward. You can monitor and control every single nanometer of the entire process, front to back. Every bit of it, in ways you never thought you could before. That creates enormous amounts of data. Very useful data about your process. It's going to become way more efficient. You're going to know far more about it. You're going to be able to do things from a process control perspective that you've never been able to do before with this capability. Where does all this data go? Where do you put it all? Has anyone actually tried some of this stuff now? I've seen like big industrial data lakes, and most organizations, when they actually put in all of these new digital sensors and create all these new data streams, they're very quickly overrun with more data than they know what to do with. Data by itself, kind of useless. It takes analytics to make it useful. Then it becomes information. So the hardest part isn't just getting data. The harder part is making that data useful back into the process, making that data useful for the organization. Which means at some point, you won't have room to store it all. It's got to go somewhere. You want that data. You really do. Not just because it's good for your process, but we'll talk about here in a minute why it's money. It actually makes the company more money, which is why you're in business, not just to make the product, push the electrons, push the water, push the gas. It's actually to make money. So if you don't have enough room in your organization to store everything, it's going to go to someone else's storage. It's going to go to the cloud. Some data center, somewhere. It's going to be in a container, probably a very poorly secured container somewhere. So as everything moves to the cloud, now we end up with a place where it's not your data anymore, someone else has access to it. And this is important because you're using all of this data in your process. You're using all of this data to make your organization better, your process better. But you're now also using this data to make money. The analytical products on your operational data are now becoming a new thing, and we'll talk about this. Before we get there, artificial intelligence is everywhere. You can't have a conference now without talking about AI. It's the new thing. It's getting to a place where AI, just like connectivity, just like everything becoming digital, AI will be everywhere. We have some models right now that can run on phones. The models will get better and better and better, and they'll get more distributed, and we'll have AI using AI to feed data back into AI. I've got a colleague that talks about how we're not going to read anything anymore. We're going to have AI summarize it for us, and that AI summary will get read to us by an AI, and then we'll tell someone else about it who will get listened to by an AI and told to them by an AI. We're going to have this between all the humans. There'll be these AI layers between all the humans doing their things. So with AI and everything, I know right now we can't trust this because I've seen some models where I try to compare, let's just say, like an IEC 62443 against maybe a NIST 800 series, 53 or 82, and it just makes stuff up. I'm like, give me a control in 62443 and tell me the equivalent control in 853. And it just makes something up, like literally, convincingly believably makes up some weird named control that looks just like it should be there, but it's fake. So we have AI confidently lying to us at this point. That's getting better. We're getting better at this, but it'll be a place where we have like an AI stack that manages a bunch of AIs underneath it that feeds a stream of AIs that gives us what we want. So we'll be using this everywhere all the time going forward. It is truly revolutionary. It's also truly frightening at the same time. Oh, and this, whoops, let me go back. Just for fun, I asked AI to read my presentation and make a picture of artificial intelligence, and this is what it came up with. I like how it feeds itself. Okay. So the OT business transformation piece is, you're now a bank. You don't remember the day you became a bank. You may think that you're an industrial company. You are. You're also a bank. We are taking our operational data, and one of the best examples is, I know of some companies that, for example, have a distribution system. It's an electric distribution system. And it's really large and runs over an interesting, it's got mountains on one side and flat land on the other, and then a bunch of water nearby. So they were finding that their transformers and some of their other equipment, despite what the manufacturer's mean time between failures said, they were operating differently. So we put in a bunch of new sensing that we can now because everything is digital. Sensing is easy, and we can get all this data back. We began to feed this into an AI and do some predictive analytics as to why certain transformers were behaving differently. Some were failing faster, some had a lot longer time. So how do we take this data and make it so that we can do better predictive maintenance, not have to roll a truck as fast or as frequently? What we found is when we would send the failed transformers back to the manufacturer was basically saying, can you give us more data? Versus just failed transformer, because that's typically what manufacturers get. They get the failed device. That's all they get. We now could send them all of that rich context around temperature, humidity, power physics, different EV chargers in the area, a new distribution facility that came on for a water plant that was nearby that they were feeding. We had all of this interesting system dynamics that we could also tell them about the environment the transformer was in when we sent it back. And we realized, why don't we sell this to them? So we've got a situation where the operational data about the operation, just what you do to make your process better and what you do to get more predictive analytics and more efficiency in your operation, can become a data product, which is an additional revenue stream for the company. You can sell your operational data through data analytical products, period. That is money. Just like the product you're producing. The electrons that they send and the meters that turn and the ratepayer that pays the bill, one source of money. Another source of money is the data about the operation to these various areas. We're even talking to a certain city that has a very high poverty rate. Poor people in a certain area, they can't pay their electric bills. They can't turn off electric service because that's cruel and it's mean, but they're talking about giving them power for free and selling the consumer usage data to cover the loss of the power. Power for free, you give away your data. It's already been done. Telecom does it all the time. Many other organizations do this. Google does it. Billions of dollars are made by Google because you just, you say things like, my shampoo smells good, or that taco, or that kebab was terrible. Billions of dollars are made on innocuous bullshit data like that. How much is your operational data worth? Enormous amounts of money. So there will be a time in the not too distant future where your organization may make as much or more money off of the data products about your operation than they do on the operation itself, which is a really weird problem. And it creates a different situation for us as OT security professionals, because we want to secure the process. This leans into our friends that showed up in the third of the room that are the IT professionals. because that product is typically moved over to the business side and secured by them, right? We don't deal with that. That's IT's problem. Issue is, that data goes out, gets analyzed, gets sold, gets reused, comes back into our process to make our process more efficient. It's left our world, something has happened, it's been massaged by AI and a bunch of other things, it's gone to somebody else's cloud. Some product from that world comes back into our process as an input. So this loop that's created, part of it in the OT space, we will have virtually no control over. Which means you have to partner up with your IT friends, your cloud friends, and your world just got a whole lot bigger and way more challenging. So, in the future, you're going to have to worry about not only the product that you make, but the data about your product, because it will directly affect your product, but also the data products about your data. This is our new world. We like to live in our OT bubble, and it's good. It's safe. We designed it that way. It's reliable. It's comfortable. This world is very uncomfortable for us. The challenge for us is getting comfortable with this new uncomfortable space. It's difficult for us as OT professionals to live in this world or to even think about these things. So we can continue to live in our bubble, and that will last maybe 5 years, if you're lucky, maybe 10. Within that span of time, your world will radically change. Really, really fast. Much, much faster than you want. And you're going to say, tap the brakes, slow this thing down. And every single thing around you is going to be like, hell no. Hit the gas. Faster. More. Because money is going to be driving this in one way, innovation is going to be driving it another way. And those two things are extremely powerful forces. Again, you're not going to be able to slow this down. It's only going to go faster. Your world's going to get very uncomfortable. So why am I saying all these things? Because I want you to just get comfortable with it. Embrace it. It's a new thing for us. It's a big, big challenge. And it's not a technical challenge. Yeah, there's some technical components to it, but it's more a human challenge. Here, in these places. Not so much just your technical knowledge or your technical expertise. You'll need those, absolutely. But you're going to need different skills than just the technical skills to figure out this problem. So that's what I'm asking you to do. Do I have a solution? No, I wish I did. I've been doing this a very long time, and I think about this every single day, if not sometimes every moment. And I still haven't come up with like the solution. There isn't one. So I'm asking all of you smart people to help me figure this out. Help all of us figure this out. We need everybody in the room getting outside their comfort zone, because all of it is going to get really uncomfortable really fast. So, that's my question to you. You are here for a reason. You're here to learn. You're here to make friends. And for those of you that, I know the engineers usually look at their shoes most of the time, make new friends. If you haven't exchanged business cards, if you haven't found someone on LinkedIn while you're here, do it. You will need to connect to other people to solve this problem. You will not be able to do this by yourself. All of us together are the only way we are going to get through this really weird and interesting future that we have that's about to happen right now. We're standing in front of this doorway to go into this new place. So that's my challenge to you as your keynote speaker for the second day. Before you leave today, make some new connections. You will need them going forward. And not just the ones that do what you do. Because as I mentioned, what you do now is about to really change, and you're going to need these adjacencies. Whether it's someone who's in the IT side or on the IT side, look at someone in the OT side. You're going to need to have those partnerships to figure this out so that when you send your data from the OT side out into that IT weirdness, and it comes back into your process, you can trust what comes back in. you're going to need to trust the person you hand it off to, not just the technology that they're using. So that is my challenge. Everyone help me figure this out, but it's going to take us all together. All right. With that, thank you so much. Have a great conference. I really appreciate it.